All right, we're going to continue graphing equations today. Specifically, we're going to graph equations using intercepts. So this is going to be an addition on to the two other ways that you already know to graph a linear equation. One way was you guys made tables of values. You just did inputs and then got outputs. Put in a value for x, get an output for y. And then you also did slope-intercept form, which are both very nice. I think you're going to like this method too. So with intercepts, we've got an x and y axis. And we've got linear equations that can be modeled with lines. The x-intercept, the intercepts are just simply where they hit the axes. So specifically, the y-intercept would be when your x value is 0. So your x value does not go right or left. That would be your y-intercept. And your x-intercept is when your y value is 0. When you don't go up or down, where does it hit the x-axis? What is x equal? Very simple way to graph lines. It's especially nice when your equations kind of look like this here. So we're going to find the x and y intercepts of the following equations, and then we're going to graph them. So we've got 2x plus y equals 8. And like I said, the x-intercept is when the y value equals 0. So essentially what we're doing here is plugging in 0 for y. And when we plug in 0 for y, it just kind of disappears, and we end up with this equation. 2x equals 8. Okay, so again, what we did was we let y equal 0. What happens when we let y equal 0? The y term just disappears. And then we can solve that equation by dividing both sides by 2. That means that when x is 4, y equals 0. And we can plot that point. Okay, now the same thing we just did for the x, we're going to do for the y. So the y-intercept is when x equals 0. So if we put x into this equation, 0 in for x into this equation, we'd get 2 times 0, which is 0. So essentially, the x term just disappears and we're left with y equals 8. Okay, that represents a point. When x is 0, y is 8. And we can plot that point. And anytime you got 2 points, you can make a line. So we'll just draw a line on our coordinate plane through those 2 points. And it looks like that. Let's do it again. 3x minus 2y equals 12. So if we let y equals 0 so we can find the x-intercept, we'd get 3x equals 12. Divide both sides by 3 and plot the point 4, 0. Okay, so when we let y equals 0, negative 2 times 0 is 0, we'd have 3x equals 12 left over, and just solve that equation. Now to find the y-intercept, we let x equals 0. 3 times 0 is 0, minus 2y would be negative 2y equals 12. And divide both sides by negative 2. That represents a point, 0, negative 6. When x is 0, y is negative 6. Plot that point, that's called our y-intercept, and make a line that goes through those 2 points. And there it is. That's the equation of that line. Every coordinate that works in this equation, every xy pair, is represented on this line. Here's another one, negative x plus 3y. All right, to find the x-intercept, I'll get rid of the y term. So I get negative x equals 6. That means positive x equals negative 6 if I just multiply both sides by a negative 1. And there's my x-intercept. And to find the y-intercept, I'll let the x value, I'll drop the x term. Divide both sides by 3 and we get a y-intercept. Then draw a line through those 2 points. One more time. X plus 2y equals negative 4. Drop the y term, we get x equals negative 4, and we've got a x-intercept, negative 4. And then drop the x term, we get 2y equals negative 4. Divide both sides by 2, and we get our y-intercept, 0, negative 2. Draw a line through those 2 points. Okay, so a point like, oh, let's see here. It looks like 2, -3 goes through this line. Well, just all of these points that are on this line work in this equation. Let's just leave it at that. All right, last one here. Tanisha is thinking of two numbers. The sum of the numbers is 5. If the lesser number is subtracted from the greater number, the result is 7. Graph the system of equations to find the two numbers. Okay. So we're going to start graphing linear systems here. Don't worry about what it is, but we're just going to graph these two equations, and we're going to look for where they cross. Here we go. So the first equation has an x-intercept of 5. There it is. And it's also got a y-intercept of 5. So here's what that line looks like. Okay, so just drop the y term, you get x equals 5. Drop the x term, you get y equals 5. And real easy way to graph that line. And now the second one, if you drop the y term, you get x equals 7. So that's our x-intercept, 7. And drop the x term, you get negative y equals 7. So actually y equals -7. And there's our y-intercept, and we'll draw a line that goes through those 2 points. Okay. Now the point where they intersect is the important point. Okay, so Tanisha is thinking of two numbers. The sum of her two numbers is 5. Well, all these points that fall on the red line here, the red dotted line, the sum of all these numbers is 5. 5 and 0, 4 and 1, 3 and 2. They all add up to 5. And then when the lesser number is subtracted from the greater number, the result is 7. So when you subtract the two numbers and you get 7, all the combinations here work as well for that. But there's only one point that works for both equations. And that is the point where they cross. And that point is, I'm a little bit messed up there, aren't I? I didn't read that right. That's fine, we'll fix it. That is at point 6, -1. Okay, and does that work? When you add those two up, do they equal 5? Is 6 plus -1 5? Yes, 6 plus -1 is 5. And when you subtract -1 from 6, do you get 7? 6 minus -1, or 6 plus 1? Yes, that's 7. So that is the only pair of numbers that when added together equal 5 and when subtracted from one another equal 7. And we did that by graphing the two lines and looking for where they cross. Okay, so today we graphed linear equations by finding their x and y intercepts. And I also kind of introduced this idea of solving a system of equations. So the one point that works in both equations. We'll get more on that later. That's all I've got for you today. Enjoy, and I'll see you tomorrow.